like connection was pretty bad, but I hope you are able to see me, and I'm going to share my screen in a little bit. And we are about 30 participants. I'm glad to be back, guys, and I'm glad that you guys are back too. And you ready to start? Okie doke, let's start. Let's share my screen. Okay, hello guys. How are you doing? We're gonna continue our probability. Well, just our statistics. We haven't really dipped into probability. Once you learn statistics, then we're gonna use statistics to get the probability. And so far we have learned about population. Do you guys remember what will be the difference between population and a sample? Remember, we started with a very small sample of having some leaves from a tree. So our tree was our population, and then the samples was where the leaves that I cut. And then some of them, they were big, some of them, they were small. So there was like a lot of variation on our sample, or maybe I hand pick our sample and make them all the same size. And quick question. So I want you guys to be participating today with your calculators. I'm gonna have my chat open. That way I'll able to see all your comments. So what can you tell me about the population? Do you remember what's the symbol for population? Or do you remember population has a mean and sample has a mean? And remember last class we talked about having a mean either for the population or for the sample. Do you remember these letters, the big letter N and the small letter N? So those were our letters for the numbers of samples. And then we also discussed about the mean of the population and then the mean of the sample. So I'm gonna give you guys a couple of minutes to remember, but can someone tell me what's the symbol for a sample mean? Yes, X bar, very good. Very good. So X were all these values. So all the data points that we collected, those are called our X's, and since they're a sample, it's called X bar. And you put a bar at the top at the X on the X. So, and I think I gave you a little hint. What about our population? You remember how it's called? Mu. Yeah, like between a U and an M, kind of like a cow, like moo, mew, mew, like a weird cow sound. And we also talk about median and mode. So do you remember what was our median? Or median was the number, yeah, the mirror variable of a set. Very good, Ava. Yep, so we do have a median, which is the middle variable, the middle number. And then the mean is kind of like the mean will be the average arithmetic mean, and the mode will be the number that it repeats the most. You guys are starting to remember? We also did a frequency distribution. We did a frequency distribution for the ages of your family members. Do you remember your homework? So we talk about that. So here's mine. So we talk about classes and groups. We talk about them having an upper class limit and a lower class limit. So this was the one that we did. So what will be what was our class width on this one? The minimal variable of a data set 3. So our class width is the class width is the number, the lower class limit. This between the two class limits, what's the difference? So that's 10, yes. So our class width on this case was 10. So 2 minus 2. So the difference between the class limits, or the difference between the midpoints, that was our class width. And this is our first class, second class. So what would be the upper class limit of the first class? 11, very good. And then our lower class limit. What about of my third class? Very good, very good. So you guys are starting to remember. So the range is also called our width. Kind of like what will be the range between our classes. So we call about the range. So the difference between 2, 3, 4, 5, 6, 7, 8, 9, 11. So that's the range between the upper class limit and the lower class limit of the first class. It's 9, the range. But the range between classes will be 10. So we also talk about our midpoints. So the midpoint of the first class was 6.5, and then you add the width. And we also talk about class boundaries. Now we had two class boundaries between 11 and 12, so our class boundary was 11.5. So this is how mine looked. So now I'm gonna talk about, we're just gonna do a quick exercise, which is called weighted average. Have you heard about weighted average? I'm right there. Weighted average. So basically, let me make this one. So whenever we do a weighted average, the most, let me go. So let me go for just a little bit because I wanted to explain. Weighted average, the easiest example that I could find about a weighted average is whenever, like for example, your grades, they have a certain weight, like each subject has a certain weight. Or for example, your homeworks, they do have so we're gonna do a little exercise, but I just wanted to kind of like understand what's like weighted average. So weighted average, for example, your homework is 50%, your test 1 is 20%, your test 2 is 20%, your final exam is 25%. So all of this, they add up to 100. So your weighted average is 100. But for this example, what we're gonna do is we're gonna use, so see, between 2 and 11, we have 7 people, 7 persons. But we really don't know which one's 2, which one's 3, which one's 7. We just know that 7 people are between 2 and 11. Let me just admit some people. So we just know that between 2 and 11 years of age, we have 7 people. So what we're gonna do is we're gonna use our midpoint which is kind of like the average between these two range, between the range of 2 and 11. So we're gonna use our class midpoint and then multiply it times 7. So what we're saying is like, we're gonna have seven people about the age of 6.5, even though it's we don't know exactly, but that's the midpoint, so that's the average. So we're gonna do our X times our frequency, which our X, remember whenever we did the histogram, our X, we said a midpoint. Some people use the midpoint and then some people use the boundaries. I like to use the midpoint just because it's the middle. So I say 6.5, 16.5. So this is your X and then this is your Y. Your Y, some people use the percent or relative frequency, and some people use the frequency, relative frequency or frequency. You can use both. But for this one, we're gonna have our X time our frequency. So over here, our X is 6.5 and our frequency is 7. So this is gonna be our weighted average. So what's 6.5 times 7? And then over here, we're gonna have 16.5 times 5, 26.5 times 3. You're gonna have to do this with your homework. 45.5. And then over here, 36.5 times 5. My next one, so 46.5 times 2, 56.5 times 4, 66.5 times 3, and then 76.5 times 3, 86.1 times 1, 85.5, 86. So 16.5 times 5, 82.5. And then 26.5 times 3, yeah, very good. 79. Thank you, Ori. Thank you, Ramya. And 36.5 times 5? 182.5. And then 46.5 times 2? 93. 56.5 times 4? 326. And 66.5 times 3? 199.5. And then 76.5 times 3? 2, thank you guys. 229.5. And then the last one was 86.5 times 1. So I knew that one. So now, once we got all of our data points, now we'll need to add them up. So we're gonna add 45.5, someone help me out, plus 82.5, plus 79.5, plus 182.5, plus 93, plus 226, plus 199.5, plus 29, this is 0.5, plus 86.5. That's gonna be a long one. But I'll wait. Very good. We got an thank you, Ori. 1224.5. 1,224.5. So, and then, so we're gonna, and then we have our N, which our little letter N was 33. That's how many data points we have, or that's like our frequency, 3, 4, 3, 6, 10, 13, 18, 21, 26, 33. So our N is 33. So now that we got our 1,224.5, now we're gonna divide it into 33. I think I got a formula over here. So do you remember what our Z, or kind of like E, Greek letter E, stands for? That symbol? Sum. Very good, Ava. So what we did is we added all of our F times X. So now the sigma is kind of like an O, and then with the line. It's kind of like the sigma sign. That's the sigma. And then this is the sum. And then this is the mu. And our N, letter N, and then a small letter N. So we added all of our F of X's because we multiplied the frequency times the midpoint, and then we add them all up. And then we got our letter N, which was 33. So now in order to get our X bar, so we divide the sum of all the values, 1,224.5 divided by 33. How much is that? So that's gonna give us our X, our mean weighted average. 37.1. 37.1. So that's our weighted average. So weighted average. So we say average, whenever we talk about average, we're talking about mean. And since we're talking about the mean of the sample, we got an X bar. So we got 37.1. So I didn't have our weighted average for this frequency distribution table. That's what we did. So we added the values divided by the N. Okay, yep, so that's what we got. We got 1,224.5 divided by 33. I made you do the harder way. That's okay, that's the way that we learn. So a quick example that I thought is that you guys are familiar. It's kind of like your final grade. It's made out of your homework, your quizzes, and your final exam. So I tried to make a kind of like an example just to see if your homework is 15%. I don't know if it's in points or in percent, but for this one, we're gonna do it in percent. So your homework is 15%, your test 1, 20, test 2, 20, test 3, 20, and your final 25. That's it. So I kind of like put here or a quick example, but I don't think I put the results this time. Nope. So we're gonna have to do them. So let's say, so what letter goes up here? Is it gonna be our F, X, or what letter is gonna be here? So I think I gave you a hint over there because here this is our weight. in percent. And then this is gonna be our X, or our frequency. And then this one's gonna be W times X. So let's say on your first homework, let me do another marker. You got a C, so you got a 70. Sorry about my crooked line. I was trying to make it, I guess, fast, but it got crooked. And then on your first test, you did pretty good. You did a 90. But then on your second test, you did a 68. And then your third test, you did pretty good. You did 85. And then your final, you did a 95. So if you have a percent, 15, and you want to divide it into 100, or you want to take out that percent, so you divide, it's 15 over 100, because it's 15 over your 100. So it's 15% of 100. So if you have, you only move 2 decimal points. So you got 100, 1, 2. So you move 1, 2. So you got 0.50, 0.15. So can someone help me multiplying? So we're gonna multiply 0.15 times 70, and then 0.20 times 90, and then 0.20 times 80, 0.25 times 95. 10.5, very good for the first one. And then what about your 18, very good. 18.0. Next one. 13.6. So all this will make your final grade. And then 0.20 times 85, 17. And then 0.25 times 95. You did very good on your final exam. So 23.75. Okay, and then what do we do? Do you remember? So we use our sum symbol, because that's our symbol of sum. So we're gonna add all this together, which is the sum of W times X. So what's all this added up? 10.5 plus 18 plus 13.6 plus 17 plus 23.75. Yeah, very good, Ori. 80, very good, Gunnar. 82.85. And then once we got this, we divide into our frequency, when in this case is the weight, which the weight total is to 100. So if we add 0.15 times 0.20 plus, not times, plus 0.15 times 0.20, 0.20, gives you 100. Or if you add, it'll give you 1. So if we add 0.15 times 0.2, 0.2, 0.2, 0.2 is 0.6. So 0.25, it's 85 times plus 0.15. How much will it give you? 0.15 plus 0.20 plus 0.20 plus 0.20 plus 1. Very good. So this will be 1. So we divide 82.85 divided by 1, which this weighted average would be 82.85. This will be your final grade. But this was very easy, fairly easy, because you just divide it into one. What about if we deleted these two? So like on your second partial or half of your semester, you wanted to say, okay, let's do it over here. So we will continue only these three. So I'm gonna try to do smaller handwriting. So let's say you had your homework, and then you had your first test, and then your second test. And then over here, you wanna know how much points out of 100 were you getting. So let's say like your homework's still gonna be 15%, and your first test is 20, and then your second test is 20, and you got 68, and then you got a 90, and then you got a 7. This is your X, and this is your weight. So what do you do? What should we do? We said, oh, we only got until our test 2, we got 68, we got 90, and we got 70. And so how do we start? So I'm gonna give you a quick, so we start W times X, and then we're gonna add, in order to get our weighted average, we're gonna have our sum of W times X divided by N, which this is our N. Multiply, very good. So who can help me multiply? So 15, we said that 15, so we said whenever you have a percent, so over here we have 15%, and it's 50% out of 100%. So we divide this into 2. So this is gonna be 0.15. So can someone do 0.15 times 70, 0.20 times 90, and then 0.20 times 68? 0.15 times 7, how much is that? Oh, very good. We got 10.5. Oh yeah, you were right. We already had it. 18.8 and then 13.6. Very good. And then if we add them all up, if we add 10.5 times 18 times 13.6, how much we get? So we're gonna say our sum of W times X is equal to 42.1 divided by, how much is our N? So what's the weighted that we have until now? 0.20, 0.20, we got 55%. So it's 55% or 0.55. Very good, Benicio. So how much is 42.1 divided by 0.55? 76.5, very good. So the sum of W divided by N is equal to 76.5. So on your, after your test 2, you were able to say, oh, I already passed the subject, 76.5. But then if you added these 2, you got it up to 82.85. So it's making sense, the weighted average. I'll take a picture and send it just in case you Let's continue. So we did this, that if you were wondering about your second, after your second test that you failed, if you were gonna, where does the 75 come from? So 75, we added, remember over here, we added all of our homeworks, it will add 100. But since we are not here with the 100, we'd remove these two. So if we remove 25 and 20, that's 45. So 100 minus 45, that's 55. But what we did is we added the first homework, the weight of the first homework, and the weight of your first test, and the weight of your second test. So all this added to 55. So 15 times plus 20, that's 35, plus 20, that's 55%. So these three things are 55% of your 100%. And then if we come back to this example, so our N over here, our total frequency was 33, our little n. So we divided 1224.5, we divided by 33, because that's our N. So we got our weighted average 37.1. So all of our data values, kind of like our weighted average was 37.1. Yeah, ask me questions. I like questions. So that's the formula. So in order to get your weighted average, which is your weighted average is your, remember we talked about there were different means or average, depending if it's for a population, for a sample, this is for a frequency distribution, but it's basically the same. You add them all up and then you divide it into how many you divide it. It's getting your average. Like sometimes if you wanna add what will be the average of heights, then you add all the heights divided by the number of persons. Good question. So any more questions on weighted average? I think it's pretty straightforward. It's kind of like an average. You kind of like add all of the numbers up, and then you divide them into your number of samples. So if there are no more questions, we're gonna continue with the next topic, which I wanted to talk about skew histogram, or since we were talking about frequency distribution, I just wanna close that one and just have, and just kind of like explain this concept. So what does skew means? Skew means like a suddenly change or direction, or something that made make a change, or it's kind of like misleading. So I don't know if you remember, but we were talking about having our data. We also talked last week about an outlier. So whenever we have our data, it could be skewed to the right, or it could be skewed to the left. Remember you did a histogram for homework? So I don't know if you guys remember how was your histogram, but most of your histogram, they weren't normally distributed. They were really kind of like a spike, or some of, because there are very few data points. So this to the left, it's skewed to the left, and this one, it's skewed to the right. But what we really wanna do for statistics in order to get the most information that we want a normal skew. So it's, let me draw it, because I like to draw. I'm not a very good drawing, but I like it. So our normal distribution is like a pretty curve. Skewed to the right. Skew to the, skew to the left and then skew to the right. What will we make, that's an open question. What will it make it look like this and not like this? Oh. So last week we talked about having an outlier. Do you remember what was an outlier? We talk also about median. We talk about, so that the average was really important in order for us to get information from our data. But sometimes the average is not the only thing that we need, because do you remember, I think I have it. Do you remember, I'll show it to you, but the example of the register at HEB and at Target, that they had the same average, but the variation was very different. So over here, we could have an outlier. So that's why this data is skewed, because it's pulling, that's why it's skewed, because it's pulling all this data to here. So you might only have one data point and then nothing, all bar, until you have one over here. So your data, it's gonna be like that. That's what's gonna be skewed. You're gonna have one little point way over here that is pulling your data or is pulling your graph. Compared to over here, this is where most of your data is. And I'll explain it on next class. I think I'm gonna explain it a little bit more why this is important and what does this, because this could tell us a lot of information. It could tell us if your point is here or if your graph's here, what does that mean? Like this is color your sigma. So what Toyota does is kind of like they only accept pieces that they have their average over here, meaning their tolerances are really tight. So this is their average. So most of their pieces, they have to fit here. If they are here, they don't accept it because this is where most of their pieces are. But I'll explain it later. For now, I just want you to know that our most important, in order to do some statistics, we're gonna need that our data is normally distributed. If not, it'll be really hard. So I put some examples over here. So you can see that the mean, the median, and the mode on the middle one, they are at the center. Do you remember what was mode? Mode is the most, the thing that occurs the most, correct. So if you want your thing that occurs the most is your average or your mean, then that's what it means, your normal. So you want like all of your points being here. That's mean, 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 mean. So let's put a quick example. I think I'm getting out of the subject, but I think it's important. So if you want your hole, or imagine you're putting a screw on a hole, right? And your hole is 8 millimeters, and you have a tolerance of 0.2 plus or minus 2.2. And you said, okay, most of our holes, they measure 8 millimeters. So you want 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8, 8. So that's your mode. So mode would be 8. And your average will be 8. And in order to have your median, that will be your largest minus your lowest. So if this is your largest and this is your lowest, if you got a positive 16 minus your negative, it's gonna give you 8. So this is gonna be your mean, your mode, and your average is gonna be the same. Compared to these two, as you can see on the PowerPoint, they're on different parts, because you're gonna have something right at the very left that is skewing your data, and then something at the very right that's skewing your data. So we always want normal distributed data. And you remember what was the difference between a bar graph and a histogram? So the histogram is, yeah, very good. They are gaps in the bar graph. Very good. And they are not, you cannot see any gaps between the histogram. So we got continuous data. Even though we might not have a person that's between 11 and 12 ages, or between 11 and 12 years of age, but we're counting the class boundaries between 11.5. So if we're gonna make a histogram, or if I did a histogram, instead of me counting from 2 to 11 and then make a space, and then from here 12 to 21, what I counted is I counted from my 11.5 over here, so that way I could join them together and make a line in the middle, and then consider a midpoint, 6.5, 6.5. Okay, let's continue with our presentations, because the most important part is about to come, and I want you to pay attention to this because it's really important, and this is the thing that you have been waiting. Let's see. Oh, let me just plug in my computer because it's running out of battery. Hold on, guys, hold on. We'll be pretty quick. Okay, so we talked about all these subjects, but we said about variation was a very important one too. So now next, I want to talk about variation. Have you guys heard or find out how we can determine the variation between samples? So variation is how the data is spread. So a quick example that I show you guys was like the experiment of having 3 people waiting at a line at different grocery stores. So one waited on a long line, and then the other 3 persons that usually go to Target, they have a person like telling you on which register to go. So they waited about the same amount of time. And then the other person is like going to HEB, that you pick a cashier and you're stuck there. So these are the results. So even though we said that the average, this was the example that I was telling you. So even though the average was still the same, the variation was really high. So which one is our highest variation? I think the third one. The third one was our highest variation. So we're gonna do a little example with that one. So there are 3 ways about getting the variation on a data set. Let me lower this thing. The first one is the range. So the range is pretty simple. It's about getting 2 points, like the range of our ages, like could be the range of our classes. So it's very simple. You get a maximum and then subtract the minimum, and that's your variation between your maximum and your minimum. So it's very easy. But the bad part about it is that it only considers 2 points, your maximum and your minimum. So we don't use this very much in statistics because it's really it's not telling you a lot of information about your sample data. It's just telling you what will be your range. And the second one is standard deviation. And it now sounds complicated, but I'll try to make it not complicated. I hope all the previous classes prepare you for this day. So we said standard deviation. Have you guys heard about standard deviation? So now you know that standard deviation is a way to measure the variation between your sample, right? Because we have talked about population, we have talked about sample, we have talked about the average, but now we're talking about the variation between your samples. So the standard deviation is the most important one and the most useful in statistics. So by standard, we mean the mean or the average. And by deviation, what would be, by deviation, we mean the separation. So how far we are from the mean. So that's basically what it means. So we said, coming back to this example, we said in order to use standard deviation, our data has to be normally distributed. So this is a normal distributed. So if we're gonna have our standard deviation, or standard means like the mean, and then deviation is how far away from the mean. So if you have a data point, this is on the bottom, you have your x's, right? So we said like our hole was 8 millimeters. So over here, your hole is 8 millimeters. And then over here, it's 8.2 and 8.1. So it's gonna, so standard deviation is gonna tell you how far is it away from the mean. So if your mean is 0.1, I mean, if your mean is 8, that's your target, and you got an 8.1, the difference will be 0.1. So that's what standard deviation is. It's the separation, or how far is it from the average. So if we talk about height, let's say we decided to measure the height for all of our STEM class. And we say, okay, an average of our class is kind of like the red line, one of the red lines, pick any. And then you see that the person in orange has a little gap between the head and the red line. So that will be our standard deviation. Like for example, if we make a line and we say, okay, so most of our team is, I don't know, maybe let's say 5 or 5.5. Let's say 5. Okay, most of us are 5 feet tall. 5 feet tall, and we said that the red line is 5, and then we said plus 3. Let's say like the blue person is plus 3, and then the orange person is minus 3. So the standard deviation will be 3, because that's how far off they are from the mean. So how far apart from the mean. Yep. So someone asked about this symbol, which is the sigma symbol, which is, it's kind of like an O with a little line. That's the symbol for sigma. So if we're talking about population, we're talking about sigma. But if we're talking about sample, we're talking about the standard deviation. We're gonna have standard deviation. We could have standard deviation from the sample, and we could have standard deviation from the population. For the population is sigma, and then from the sample is the letter S. And the third way to get a variation for your sample is called the empirical rule. So this is what I was talking about, kind of like having a normal distributed data, and your line at the center is your median, or is your average, is your mean. So everything is added to 100%, So if you have a perfect curve, the middle will be your 50% of your data is to the right, and then 50% of data is to your left. And then you could divide that into another 2 categories. So if you divide it into like 4 quarters, you're gonna have 25, 25, 25, 25. So 50% of your data will tell you 68% of the information of. I know it's getting confused, but I'll explain this a lot further into next class. But now we're gonna go into the standard deviation. But I just want you to know that the empirical rule, it's like it's getting information whenever you have this graph. And it's the empirical rule, it's 68, 95%, and 99.7%. So 68% of your data will fall between the first 25 and the third 35. So let's see. So we said, sorry that I don't have this very good, but hope you understand. Let me know if you have questions and we'll go over next class, but I just wanted to understand it. So this is 100%, right? So you got your data and your histogram, and this is all 100%. So if we divide it into half, this is 50%. And if we divide it into another half and then another half, this is gonna be 25% and this is gonna be 25%. And then everything is gonna go to 100. So this 25 and this 25 and this is 25 and this is 25. So 68% of your data will fall between here and here. So even though if it's 50% like here and here, all this is gonna be between 1 sigma and it's gonna be 68% of your data. And then if we account for another 25 percentile, it's gonna be over here and over here. And all this counting from here to here is gonna be equal to 95% of your data. So whatever your X is here, if your X over here, it says 8 millimeters and it's 8.112 and over here is 12.22 or 12, or depending on what our tolerances are, meaning that 95% of our data will fall into here. Maybe that's the results that you want. You want to accept 95% of your pieces. Then you're going to have a higher, if you want to accept 95% of your pieces, your range has to be larger. But if you want to accept 68% of your pieces, your tolerance is going to be lower. So if you want all your pieces to be 8 millimeters point, very close tolerance, that means you're gonna have only 68% out of 100, because this is all your pieces. So all of the pieces that are under here, there are 100 pieces. I mean, not 100 pieces, but 100%. So 68%, if you pick 68%, you're gonna get less pieces. But if you want 95, you're gonna have your X's to be larger. And then if you want 99.7, you're gonna go even further here. So this is, if you're 99.7. Why 99.7? Will you be, once you get to like 1,000 of data points, will you be able to measure all of your data? It'll be really hard. That's why you always get a 99.7%, and that's pretty accurate. Like you always gonna get an outlier. That outlier pulls your data down here, and then you're over here gonna get an outlier that pulls your data all the way till here. So I hope you're following me. If not, we'll continue to do some exercises. So number 2, The most important one will be standard deviation. And of course, we're going to have a standard deviation for our sample, and we're going to have a standard deviation for our population. So the difference between our sample and our population, so if it's going to tell how the data is spread from the mean. It's going to tell us how the data is spread from the mean. So the mean from population is mu, and then the mean from the sample is x bar. So here is the formula that you have been waiting for. You wake up this morning and say, oh, I hope Miss Elbjorn give us the formula for standard deviation. So it's gonna have a little bit of math, a little bit more complicated math that we have seen, but I think you'll get it. So we said, we have a couple of rules. So we said, so standard deviation for a sample. So we said standard deviation for our sample. So we said sample standard deviation. Let's pick the example for the HEB cashiers. No. Let's see, we picked the HEB cashiers. I don't remember I think it was 1, 3, and 14, the minutes that they wait. Let's see, okay, so I want you to do this with me. So I guess the one that it has the most variation was the one with the cashier. Probably the last one was me, that I always wait a long time. So let's do, so here, this will be our X. So that's our data point, right? So this will be our X because we're getting data points. And then we have 3 data points. We have 1, 3, and 14. And this is gonna be our sample standard deviation, because we are not counting everyone that went into the store. We're just counting 3 persons. So this is our sample standard deviation, okay? And we said that the symbol for our sample was S, and our symbol for our population was sigma, which is like a circle and then a line. That's the sigma. That's the standard deviation for the whole population. So we'll continue to do the formula that you have been waiting your whole life for standard deviation. So we said that the standard deviation follows that. How far away from the mean was our sample? So first we got our sample, which we got our X, we got our X's. This is our sample. And we said how far away was from the mean. So whenever you wanna do how far, like how far is something, you kind of like subtract. So we're gonna subtract our sample from our mean. So what's the symbol for sample mean? N is our total sample. So over here, our N, what will be our letter N? Mu, someone says mu. So over here, a letter N will be 3. But that's not our sample mean. Our sample mean, it's another letter. Someone says mu, okay? So we said a mu was like that. What was mu? Mu is the mean of, let me go back because this is important. Someone says mu. Someone said the right answer, but Okay, so we over here we have a mu. So we said mean for sample was X bar. That's the mean of sample. And then the mean of the population. Are we talking over here about population or sample? We're talking about sample, right? Because it's a nest. If it was sigma, then we're talking about population standard deviation. But we're talking about S. S means sample. So very good. Toby says X bar. That's correct. So we're talking about our sample. So we said how far our data point was away from the mean. So remember we said like, let me go back to my little. So we say how far our data point was from the mean. So if this is the mean, how far from the mean? So we subtract the X minus the average. Let's go back. Let's go. Okay. So we got X minus X bar. And then we have okay, I'm going back to this again. So some data points are gonna be to the right and some data points are gonna be to the left. Are you following me? Some data points are gonna be to your right and some data points are gonna be to my left. So if I subtract a data point from the average, some of my data points are gonna be negative and some of my points are gonna be positive. Do you agree? Because we are subtracting. What about if my data points follow below? Or what about they're above? I could have 8.2 minus 8, that will be 0.2. But I could have, 0.8 minus 8.2, that will be minus 0.2. But then I could have a 7.8 minus 8, then that will be minus, I don't know, I could have positive and negative number. So if we want, what do we do in order to make a negative number positive? So I'm gonna give you a little hint. So we square it. We square it, and that way, even though if we're gonna have a negative or a positive, we're gonna convert it into a positive. So whenever you square something, it's always gonna be positive. Yeah, very good. So we're gonna square it. And then we're gonna do this for all our data points. We're gonna do this for all our data points. So over here on this example, we're gonna take our average. So we're gonna add 1 plus 3 plus 14 divided by 3 to get our average, to get our X bar. To get we could do, to get our X bar. And then we're gonna add them all up to get like all the difference. So if we are gonna add them all up, we're gonna have this Greek sign that is kind of like a plus. And we, in order, if we square it, we take out the square root, kind of like simplifying it, like squaring it, and then the opposite that way. And then if we're gonna get if we're getting the average, we're gonna divide it into we're gonna use all the total numbers, right? Because whenever what do you do in order to find the average? You add them all up and then you divide it into the amount that you're counting. So you add them all up and then you're gonna divide into your number of samples. But do you remember what was the letter for the number of samples? Was it the big N or the letter N or the little n? Was it the letter N or the little n? This was the number of total. One's for population and then one's for sample. Very good. So this one, samples. Number of total of population. Very good. And we're gonna do something little different over here. So let's see. Oh, so far we got X minus the average. And I think I gave you a little hint over here. So we subtract 1. But I want to explain you why we subtract 1. Remember, this is a standard deviation of sample. So whenever the sample is not going to be exact, it's a sample. So you always want to overestimate your sample. So because you're making conclusions for your population, instead of counting the whole population, you're taking a sample and then making sure that sample represents the whole population. That's why we remember we use a random sample. We try to make it as random as possible. So whenever you divide by a smaller number, your sample will get larger. So we overestimate. So in order to overestimate, we subtract 1 in order to make it our denominator smaller. So the whole thing gets bigger. Any questions on this formula that you learned today? This is the most important formula, guys. I'm proud of you that you're getting the idea that there's a difference between a population and a sample. And there's a difference between the total, the mean of a sample and the mean of the population. And also how far your sample data points are away from the mean. And then you divide it by the total. So this will give you the variation of that. Is subtracting 1 opposed to not count the mean because the deviation from the mean of, is subtracting 1 supposed to not count the mean because the deviation from the mean? Yes, the deviation. Yeah, so what we want to do, the smaller the number gets, the closer you are to the mean. And the larger your sample deviation gets, the farther it is from the mean. So if your sample deviation is closer to 0, you are totally right. So for example, this is your mean. So this is 0. So you want to be close to your mean, but your sample deviation, if it gets farther away, so this is like your variation, it's away from the mean, it's gonna be larger. It's gonna be like 3, 4, 7. 7 is like way farther over here. But if it's close to 0, it's pretty close. It's pretty close. But if it's like, it's a 1, next class we'll talk about, I'm gonna explain more this graph. And right now I want us to do this, like we have this example on the grocery store, and I want you guys to use this formula to get the variation of these 3 data points. Let's continue. Any more questions on this formula that we just learned today? Okay, if not, I'm gonna continue. And there's same formula, but instead of a sample, we got population. And the population is the sigma. Sigma. Sigma is the standard deviation. This is sample standard deviation. Sigma is population standard deviation. So same concept applies. So we're trying to have our data points, how far your data points, you're still gonna have data points because that's your input. We're gonna see how far they are from the mean. Well, over here, the mean was X bar because X bar was the mean of the sample. What's the mean of the population? Someone said earlier. Mu, very good. So we're gonna see how far our data points is from mu. And then you remember what we do in order to don't have negatives and positives? We square it, right? Very good. Ori, we square it. Very good. Yeah. And then we add them all up. So we have the sum of all of our data points. And then we take the square root. And then we're gonna divide. We're gonna divide this one by which letter? By the total of our total population, right? Very good. Our letter N. On this one was our little N. This one is our letter, our big N. Do you think we're gonna subtract the -1? Because over here we're talking about a sample and we wanted to overestimate. But over here, since we're talking about the whole population, this one doesn't have the -1. Very good. This one doesn't have the -1 because we're talking about the whole population. So we're not overestimating. We're talking about the population. So this is the formula for sigma. Do you guys find the similarities between this formula and this one? It's basically the same, right? We're talking just about two different things. One's our sample and then one's our population. Yep, that's the big difference, that there's no -1 on this one. Okay, I think I'm jumping in. So I'm gonna show you another, well, let's do this example. So I wanna do this example first. So we said we have our X minus X bar. So we have X minus X bar, right? So what will be our X minus X bar? So is there our X bar? Can someone add up for me 14 plus 3 plus 1? That's 18 divided by 3. X bar is 6, very good. X bar is 6. So we got 1 minus X bar is 6. How much is it? -5, right? Mm-hmm. This one is equal to -5, -5. And then 3 minus 6 minus 3 And then we got 14 minus 6, 8. 8. And then we said that we need to square it. So we're gonna have x minus x bar squared. So we got here a -1, -5 squared. How much is it? 25. Minus 3 squared, 9. 8 squared, 64. Okay, so far we got x minus x bar, x minus x bar. We got -5, -3, 8, and then square it. We got 25, nice. I like to make a graph just because I can see it more clearly. And then we said we added all these ones. So we're gonna add x minus x bar squared. So what's the total? Equal 25 plus 98. Very good. 98. And then we have n minus 1. So 98 divided by n minus 1. N is 3. 3 minus 1 equals 2. So, okay, our formula is square root of x minus x bar squared divided by n minus 1. So we got x equals square root. The sum of x minus x bar squared was 98 divided by n minus 1, which is 3 minus 1. It's equal to square root of 98 divided by 2. How much is it? 7. So we got s is equal to square root of 49, which is equal to 7. Very good. I'm gonna show you another quick formula. I don't think I wrote it down, but I think it's important you just to have it. So there's another way to get the variation. So this is very simple. They're the same, but this will give you the same result. Depending on what data you got, you could pick which one you use, but I just want you to have it. So we got n, which you know your n is 3, times the sum x squared minus sum x to the power of 2 divided n times n minus 1. And then square root. Let's do this. So I'm gonna put this example on green. So we got our same data points. We got 1, 3, and 14, right? So these are our x. And then over here is asking us for x squared. X squared. So we're gonna have x squared (1 to the power of 2). 1. 3 to the power of 2. 9. 14 to the power of 2. That's a hard one. 196. And then it says add all of your x squares. So if we add all this together, so this will be the sum of your x squared. How much is it? 1, well, that's easy. I guess 1 plus 9 is 10 plus 196, 206. Very good, Ramya. So 206. And then we got over here the sum of all the x's. So what's the sum of all the x's? So this is our x's. So the sum of x's is 1 plus 3, 4 plus 14, 18. So we got 206. So over here is saying S, I'll try to do smaller. So S is equal to square root. And what's our N? N will be equal to 3. 3 times, what's our sum of x squared? We said 206 times 206 minus the sum of x minus 18 divided by n. We said our n was 3 times n minus 1 will be 3 minus 1. Can someone do 3 times 206? Can someone tell me a mistake that I'm making? I'm missing something. Like over here, I'd say the sum of x, but I'm missing that square. You see it? Yeah. So I'm missing this square. Because we add them all up, but we didn't square it. So we're missing this one. Minus. So what's 18 squared? 324. 324. Divided by 3 times 2, that's 6. And then square root. How much is 618 minus 324? 294. 294. Divided by 6 square roots. How much is this? 49. Square root of 49. All right. So we got the same result. S square root of 49, 7. So S, 7. What do you think? You think this is hard? You understand it? I'm glad. This is the most important part. So do you think we can do this example? 4, 7, let's do this. Because we did have, so that's the, so if someone had asked us, okay, on the third example that we got the cashiers, what's the standard deviation? So the standard deviation is 7. What does it mean? It's, yeah, you need to remember the equation. And even though you remember the equation, once you know, is it a population or is it for a sample? Are we talking about mean of a population or for a sample? Then you start plugging in these variables and it start becoming easier. Are we talking about a little n or a bigger n? And then you start talking, but I wanted you to understand kind of like the basic concept. So on this example that we said 1, 3, and 14, our variation or our sample, like our standard deviation was 7. So if we have this graph, meaning like you got one person that waited 1 minute, and then you get another person that waited 14 seconds, but your average is 7. So your sample standard deviation is way high. It's 7. You want it to be close to 0. So it's really high. So it's one person is way over here, one person is way over here. So it's not yeah, so it's 7. But let's do this one, the one that waited one line. We got 4, 7, and 7. So we got 4, 7, or 7 as our x's, and then we'll do the standard deviation. So which formula do you guys want to use? Do you want to use this one or you want to use this one? Doesn't matter to me, pick one. The first one that we use. Okay, let's use that one. So we got our x, we got 4, 7, 4, 7, 7. So we said we need x minus x bar and then square. So we need to get the average. On this formula, we don't need to get the average. That's kind of like a difference between this one and this one. This one, you don't need the average. What you need to do is kind of like have the square root of, or yeah, the square each x, and then add them all up. Once you add them all up, one will be square, and the other one will be just times the number of n. So this one is a little bit more simple. I guess they're the same, depending on what your data are, or depending on what information are you giving. So this one, we do need to have our x bar. So see, on this one, you need to have our x bar. So can someone give me our x bar for 4, 7, and 7? So we got 4 plus 7 plus, and how do we get our x bar? It's like any other average. So we add all our numbers divided by the total numbers. So we're gonna have 7 plus 4 divided by 3. Someone, very good. So that's 18 divided by 3, that's 6, or n is 6, which that was right, because over here, our average was the same, but we wanted to know what was the variation. So we're expecting the variation to be greater or less than this example, our Frexer sample. Less, right? Because these are supposed to be closer, but we don't know that. That's where we're getting our sample standard deviation. So, okay, so let's do over here, we got x minus x bar. And then x minus x bar square. Okay, so we got 4 minus 6 is equal to minus 2. And then 7 minus 6 is equal to 1. 7 minus 6 is equal to 1. So minus 2 squared is equal to 4. 1 squared, 1. And then 1. And then what do we do? Add, very good. So we follow our formula to x minus x bar square, we got that. And then we got this symbol, which is add. So we're gonna add x minus x bar square. So what's the total? 4 plus 1 plus 1 is 6. So we got the sum, it's equal to 6. So let's start making this formula. So we got square root of I'm running out of space, but is the sum of x minus x bar squared divided by n minus 1. So we got x is equal to the sum, which was 6 divided by our n, which our n was, no, I got it, like this is our x bar, not our n, and n is 3. Is 3 minus 1. So our s is equal to 6 divided by 2. So that's 3. So our s is equal to square root of 3. Very good. So x is equal, what's the square root of 3? (1.73). Very good. Is this a lower sample standard deviation than 7? Way smaller. Way smaller. So that means our data points, the variation is way less. But yeah, but this one you got a 1 and then you got a 14. This one you got a 4 and then you got a 3. So for you guys, do you want us to keep it in root form or change it to decimal? It's always in decimal because it refers to, it's always gonna be, it refers to this graph. So this is 0, and then you got 1, plus or minus 1, and then plus or minus 2, plus or minus 3, and then if you got, so it goes both ways. So yeah, decimal. But I wanna show you something. And then we got something called variance. So variance, this is your standard deviation. But once you have your standard deviation, you can get your variance. So of course, we're gonna have a variance for our sample, and we're gonna have a variance for our population. But once you get your standard deviation, it's really easy to get your variance. Or once you get your variance, it's really easy to get your standard deviation. So tell me, can someone tell me what's the standard deviation of a sample? What's the symbol of a standard deviation of a sample? Or what's the standard deviation symbol of the population? S, very good. S. So if we're talking about sample, standard deviation is S. What about population? Sigma, very good. Sigma. And then, in order to get the variance, we're just gonna square it. So this is how you get the variance. The variance is just square. Your sample standard deviation square. So can someone tell me that these two are samples? So we cannot get the sigma because we're not talking about population, we're talking about samples. So can someone tell me what will be our variance for the first segment for 1, 3, and 14? We said that our standard deviation was 7, and this one is S squared. So what will be the variance for this, our first set? 49, very good. So it's the number inside your square root. It's the number inside your square root. So what will be here is the number inside. Before you square it or before you take the square root, that's your variance. So someone asked me, Lucy asked me if we want it in decimal or in root form. If you leave it in root form, it could also get confused with your variance because it's square and this is your 3. Any questions so far? Just out of curiosity, when are we supposed to finish the meeting? I think 6:30. Oh, it's 6:46. I think we went a little bit over. I guess I got excited, or either I got excited or it was just too much to cover. But I hope you guys are able to. I just want to wrap it up really quick. That way I don't want to take most of your time. And since we didn't have a class on Tuesday, I think it was good. And I just got confirmation that we're gonna have our workshop, like a 3D workshop. So I think that'll be pretty cool for you guys to get, I guess, experience to that field, even if you're interested or not. It's always good to get exposed to many fields, but a 3D CAD, it's something that you can be using any field, in construction, in this, if you want to be a designer, if you want to be a gamer, if you want to do landscaping, it's very cool because you can do stress analysis of materials. You can do how fatigue of a hinge, like how many times until it breaks, or you can simulate cars or how fast it's gonna take in order to fail. It's pretty cool. Everything is like joins together. So guys, thank you so much, and I hope you enjoyed the rest of the evening. I'll stay for a couple of minutes just in case you have more questions, but I hope you guys are able to grasp these concepts of standard deviation and sample and population, and I hope you're getting more familiarized with these concepts, and whenever you see them in class, they're not as strange as they usually are, or they were for me. Thank you. Have a great evening, guys.